Hello students, today we are going to solve one more problem from optics and that topic is young double slit. This question basically asked in IIT JAM 2018. Okay, that's a really interesting question. So in that question, there is a two slit. There is a two slit S1 and S2 and you have a screen. Okay, separation between these two slit, that is D. Separation between slit and screen, that is capital D. This is your screen. Okay, now both slits are basically covered by some medium or some material. Uh, the thickness of both plate. So in front of both slits, you have some plates. Okay, and the thickness of this plate, both plate is same. That thickness they have provided. Okay, but the refractive index is given. That is N1 and N2. The refractive index is different, but their thickness is same. Okay, and thickness value they have provided, that is basically 6 into 10 to the power minus 6 meter. Okay, and they have used that light for this experiment having wavelength lambda equals to 550 nanometer. Okay, so when they covered these two slits uh, by some slab having same thickness with different refractive index N1 and N2, then what they have observed, that seventh bright fringe seventh bright fringe is basically shifting to central bright. Okay, then the question is, what will be the value of difference in the refractive index? This value they asked. Okay, that's a really interesting question, because when they covered this slit by two different slab, then seventh bright basically shifting to central bright. Okay, and you have to calculate their difference in that refractive index. Okay, so let us solve this question. Okay, now let us consider P is the central point. P is the central point, but this is not central bright. When you cover this slit by some slab, this central point will no longer be your central bright, because central bright will be shifted upwards or downwards depending upon thickness and refractive index. Okay. Now I don't know where the central bright will be, but somehow if I can calculate the position of central bright, then I can calculate the position of nth bright fringe. Okay, so let us choose some arbitrary point Q, and this point is basically the central bright. Okay, so I have considered this Q point is basically central point, and the distance between P and Q, let us assume this is y. So somehow if I can calculate the expression for y, then I can calculate the position of seventh bright. Okay, so let us define this angle. Let us define this angle is theta. Let us define this angle is theta. Okay, since this point is central bright, so obviously the optical path between S1Q and S2Q, that should be same, because for central bright the optical path of two rays S1Q and S2Q, that should be same. Now let us calculate first that optical path. Optical path when that ray is going from S1 to Q, that optical path will be how much? That will be, so some of the path is going in the air, that path will be, or path length will be how much? S1 Q minus T. This much length is going through air. So optical path corresponding to this length will be how much? S1 Q minus T into refractive index of air, that is 1. plus some portion or some part is going through that slab. That amount is how much? T. T. So optical path will be how much here? T into N1. So this is the optical path when that ray is going from S1 to Q. So some of the portion is going through air. That portion will be how much? Total distance minus this distance. So optical path will be how much? S1Q minus T into refractive index of air, that is 1. And T part or T length is going through the slab. So obviously optical path will be plus T into N. Similarly, optical path when ray is going from S2 to Q, that will be how much? That will be, again, if you apply same rule, so S2Q minus T, this much amount is going through air, so optical path will be S2Q minus T into 1 plus T amount is going through N2. So you have to take this part also, T into N2. Okay. Okay. So now since Q is central bright, so these two length should be same. So what I can say that S2Q minus T plus T N2, that should be equals to S1Q minus T plus T N1. Okay. So this T will be cancelled and I will get basically S2Q minus S1Q, and that should be equals to T into N1 minus N2. Okay. And I can calculate this S2Q minus S1Q. So this part difference S2Q minus S1Q, this is the geometrical part difference between S2 and S1. And this thing we generally derived in Young double slit, that is nothing but d sine theta. The geometrical part difference between S2Q and S1Q, that will be d sine theta. That should be equals to T N1 minus N2. And since theta is small, so in place of sine theta, I can write theta. Again, when theta is small, in place of theta, I can write tan theta also. So basically, what we can say, for small theta, I can substitute sine theta equals to tan theta. Okay, so now I can substitute in place of sine theta equals to tan theta because theta is small. T N1 minus N2. Okay. Now tan theta I can calculate because this is, if you consider this is a triangle. If this is a triangle, then perpendicular will be y, base will be capital D. So in place of tan theta, I can write y by capital D. That should be equals to T N1 minus N2. So it means the position of central bright will be how much? It will be basically D by small d T N1 minus N2. N1 minus N2. Okay. So we know if we can calculate the position of central bright, okay, then I can calculate the position of nth bright. So position of nth bright will be how much for this case? So it will be n d lambda by small d plus d by small d T N1 minus N2. Okay. So this is the general expression for position of nth bright fringe. Okay. Okay. Now, so what will be the position of seventh bright? That will be, in place of n, I have to substitute 7. So it will be basically 7 d lambda by small d plus d by small d T N1 minus N2. Okay. This will be the position of seventh bright. According to given condition, that position of seventh bright will be where? It will be at center, at P. So it means the value of this y will be how much? It will be 0 because they have given the position of seventh bright is now at central point, and at central point obviously that length will be how much? 0. So what I can say, this value should be 0. So 7 d lambda by d plus d by dt n1 minus n2, that should be equals to 0. Okay. So from here I can calculate that modulus of n1 minus n2. Modulus of n1 minus n2, if you calculate, so d capital D by small d, that will be, you can take common. So basically if you calculate it, you'll basically get 7 lambda by t. Okay, just rearrange, if you rearrange this equation, this will be cancelled, capital D by small d, and you will basically get modulus of n1 minus n2, that will be 7 lambda by t. Now I know lambda and t, so I will substitute this. So 7 lambda is given, that is how much? That is 550 nanometers. So I can write 550 into 10 to the power minus 9 meter. And t they have given, that is 6 micrometers. So it will be 6 into 10 to the power minus 6 meter. Okay. So if you calculate this value, I have calculated, you will get this will be equals to 0.64. This will be 0.64. So mod of n1 minus n2, that will be 0.64. So really interesting question. Okay. So what you have to do, you have to find the position of 7 bright, and you have to equate that equal to 0, because it is at p point. Okay. Now if you rearrange this equation, you will basically get 7 lambda by t. So very simple mathematics is there, algebra. Now if you can calculate this value, you will get basically 0.64. Thank you.